Greetings everyone, welcome back to another mathtastic lesson from yours truly, Mr. Ireland. Today we're going to talk about circles in the coordinate plane, and this is chapter 10.7 in our textbook. Our objective is going to be to learn to write equations of circles using the center and radius. So on this slide here, you will see the standard equation of a circle. Let me go ahead and highlight the portion that is of interest here. And let me go ahead and read that out to you. So we're going to take the quantity of x minus h squared plus the quantity of y minus k squared, and that's equal to r squared. And this is called the standard equation of a circle with a center of hk and a radius of r. That equation might look real familiar to you because what you have here is the Pythagorean theorem, just in a different form. Imagine this as your A, and this as your B, and this radius as your C. And you might again notice some similarities to the Pythagorean theorem there. A squared plus B squared equals C squared. Alright, so just keep that in mind as we progress through the problems on the next few slides. Now, again, this is the standard equation of a circle, and I have it nice and color-coded for you. Keep in mind that there is a subtraction sign here at all times. There's a subtraction sign right there that you always have to be mindful of, and another one right there. All right, and our center is HK, and our radius is R. So let's try some problems here. All right, example 1a says, write an equation of a circle with a radius of 6 centered at the origin. The second question says, write an equation of a circle with a radius of 20 and a center of -5, 2. So for part 1, remember that the origin is the point 0, 0, and our radius is 6. So with that said, I am going to substitute 0 and 0 into the standard equation of a circle, and I'm going to substitute the radius of 6. Now, how do you simplify that? Well, we know x minus 0 is just x, so we get x squared, and we know y minus 0 is just y, so we get y squared, and this is equal to 36, and that's how you would write the standard equation of a circle. Question B, we're going to go ahead and substitute. So again, it starts with that standard equation of a circle. This is our h, -5. So you plug in x minus h squared plus y minus k, which in this case is 2 squared, and that's equal to 20 squared. Again, how do you simplify this? You're not going to use the FOIL method or any special products or anything like that. All you do is write it out in this form. And you write x plus 5 squared plus y minus 2 squared is equal to 400. Make sure you simplify your r squared portion. Make that 400. But do not try to FOIL this out. Leave it just like that, because this gives us the center of the circle. So I want you to pause the video and try these next two problems out. Here you're going to have to look at the picture and get the center and radius from the circle itself. Down here is another similar problem to the other ones that we just tried. So pause the video for a quick second and try these out, and I will get back to you in just a moment. All right, so now hopefully you pause the video. Let's go over the solutions. So in part A, we're going to have to realize that we have a radius of 1, 2, 3. So R is 3. And we have a center of 0, 0. Right there, you have another center origin 0, 0. When you plug all that in, you get x squared plus y squared equals 9. Down here, your h is 7, so you have x minus 7 squared plus y minus -6. Notice this sign essentially reverses. So you have y plus 6 squared. R squared is 15 squared, which is 225. And that's our solution. All right, so let's go ahead and move on here to our next problem. Here we have a radius that has a radical, and we have a center of 0, negative 9. So all we're going to do here is plug in our h, which is 0, our k, which is negative 9. All right, and then our radical 10 squared. Now remember, a square and a square root are inverse operations, so they will cancel each other out. So our final answer here is going to be what you see right here, x squared, because x minus 0 squared is x squared, plus y plus 9 squared equals 10. Again, remember, these two double negatives will just make positive, and then the square root and the square cancel out and leave you with a 10. All right, again, please pause the video, try this problem out, and we'll check back in about a minute or so. All right, so this is your solution. Again, x minus 6, your h is 6, so basically the sign is reversed. Your k is negative 5, so here these two are going to cancel out. And then our radical 7 squared just makes 7. And this is actually our final answer. I misspoke on the earlier side, but this right here will be your solution. Nothing else to do. Don't FOIL anything. You're all done. All right. So our last example. So this is a little bit different from the prior two, but not too many extra steps. So here we have a point negative 5, 6 is on a circle with center negative 1 and 3. And we're going to write the standard equation of this circle. So as you can see here, we have our center right there. Now we have a circle that we can count the radius out for, but I'm going to pretend like that circle wasn't there and we weren't able to do that. So this is the way you would want to proceed. So you're going to substitute your hk, and that's going to give you x plus 1 squared plus y minus 3 squared is equal to r squared, because the problem makes no mention of r. All right, and the next step is you're going to take that point that's given, and you're going to substitute that point into x and y. So up here, notice they give you negative 5 and 6, which is this point out here. It's a point that's on your circle. And that point we want to substitute for our x and y. After doing that, we're going to simplify. That's going to give you negative 4 squared. This is going to give you 3 squared, which further simplifies to 16 plus 9, which is equal to r squared. 16 plus 9 is 25. All right. So now keep in mind, in the standard equation of a circle, you want to have the value of r squared written right at the end. So here is your final solution. So you are going to have your x minus h portion right here, x plus 1 squared, as you can see right down here, x plus 1 squared plus y minus 3 squared, and then r squared. This entire value here, r squared, is 25. So I know the radius is 5, and there are other ways to figure that out. Some of you may have seen or may have wondered, well, why can't I just do something like this? Or some of you may just have counted the radius. Maybe you just said 1, 2, 3, 4, 5. Yes, the radius is 5, but if you didn't have the drawing in front of you, that may not have been as noticeable. But you could use the Pythagorean theorem like I did here and say, this is 4 and this is 3. So I know 3, 4, 5 triangle, this radius is 5. So my r is equal to 5. But again, you would not plug in 5. You want to plug in 25, which is r squared. Okay? You could also use the distance formula. If you'd like, you could use the distance formula between your center and your point, and that would also give you a distance of 5. So a lot of ways to do this, but this method here is probably the easiest way to get to your standard equation. All right, so one last problem, and we will be done with our lesson for today. So go ahead and pause the video for a bit, and you'll notice same type of question. The point 41 is on a circle with center 2, 5. Write the standard equation of the circle. And notice you do not have a graph here of the circle. So you're going to have to use some algebra. You're going to plug into that standard equation. So pause the video for a bit and give it a shot and check back for your answer. All right, so hopefully you pause the video, and here is our step-by-step solution. Here's our center, 2, 5. Plug that in, x minus h squared plus y minus k squared equals r squared. You can substitute x, y, h, and k all at once. That's not a problem. But here, I just wanted to kind of show you guys just step by step. So the x is 4, the 4 here. The y is 1, so that's where we're getting 4 and 1 from. And we plug those in. And you'll notice we'll have 2 squared plus negative 4 squared. 4 plus 16 gives you 20. So 20 is equal to r squared. Now remember, normally you'd solve for r and figure out what the radius is. But we're just asking for the standard equation of a circle. So you're just going to take r squared, and you're going to plug that in right at the end here. And this is our final answer. All right, so before I let you guys go, I want you guys to watch a video that MCI created called Circle Mode. And in Circle Mode, he talks about the standard equation of a circle. So that's this lovely video right here, Circle Mode. There is a version 2, which was made by one of MCI's former students. But check out both. But this is a great one to watch. I'm going to click on it here. You may hear some of the volume.
Circles round, circle mode. You got circles here and there.
All right, so give that a view. I'm sure you guys will like it. Talks a lot about the standard equation. You'll see the same equation we talked about here and some examples. A lot of good stuff. So go ahead and give that a look, and let me know if you guys have any questions. Send me those Schoology messages, Google Classroom messages. I'm working on getting Zoom conferencing set up, so we'll have a Zoom session real soon. I'll let you guys know, and we'll meet up. We do have a test on Monday coming up, so be prepared for a review on Friday, and over the weekend we will have some time to study, and on Monday we're going to have a Schoology online test that I'll talk more about later this week. All right, take care everyone, stay safe, and hear from you guys soon.